We're about to work with compound inequalities. If you can solve a single inequality and graph the solution set on the number line, then you can solve a compound inequality, especially if you remember how Venn diagrams work. The reason for that is because a compound inequality uses the word and the word or, which are the exact same words that are used in our work with sets. Remember, please, that the union is the set of elements that are in A or in B. Union means to unite or take all. If you think about it, let's suppose you work for a very large company who needs to hire a lot of people. And you can use people who are good at typing and filing and working behind the scenes. And you can also use people who are very good at customer service, who can be in the front and meet customers and satisfy their needs. And because you need both types of employees, you're willing to hire behind-the-scenes clerks, and you're willing to hire customer service people, and so you're willing to hire the union of the two and take all. However, if you're a small company and there are times when you're going to need someone who's good behind the scenes, and there are going to be times when you need somebody who is good with customers, and you can't afford to hire everybody, then you need someone who's in the intersection. You need someone that can do both, who can work with customers and work behind the scenes. And for that, you're going to use the word and, which means in both. Let's see how that works with inequalities. Solving x bigger than or equal to -1 means the numbers in this part of the number line. X less than or equal to 2 are the numbers in this part of the number line. If you want a number to be bigger than -1 and less than 2, then you want the numbers in the intersection, which are right here, which is exactly why we shaded the area of the number line that was in both. And because we're in Algebra 2 and we've been practicing set builder notation, you'll notice that the solution set was written the way we learned it before. All the real numbers such that x is between -1 and 2. Example 2 uses the word or. We have the same x bigger than or equal to -1. We have the same x is less than or equal to 2, but the word or means take all, and if we take all, we end up with all real numbers. In this example, the inequalities go in the same direction, as they say. X less than or equal to 2 is down here. X less than or equal to -1 is also down here, and one is inside the other. When we have the word and, which means in both, we want the smaller one, because if you're less than or equal to -1, then you're also less than or equal to 2, but there are numbers that are less than 2 that are not also less than -1, and those numbers are no good. That's why we shaded the area that was less than -1 and didn't use the numbers that were no good. And the solution set showed that. In example 4, the word or means in both. So now we'll take the bigger one or the smaller one, if our choice is between a bigger one and a smaller one, and we're told to take all, then I'm going to take the most I can, which is all the real numbers less than or equal to 2. When you work with compound inequalities, whether it's and or, one thing you can do is use the number line and make a little Venn diagram on the number line, and then use what you know about and being in both and or being take all, and shade the appropriate sections of the number line. But you absolutely must summarize your findings by writing a solution set in set builder notation. Our last two examples, 5 and 6, use less than -1, which goes in one direction, with bigger than or equal to 2, which goes in another direction. Or simply means to take all, and the only way to summarize that is to rewrite less than or equal to -1 or greater than or equal to 2 in the set builder notation. And between two disjoint sets, in which you have to be in both places at the same time, which is impossible, is no solution. As we said before, compound inequalities are inequalities that come in two or more pieces, just like the ones you studied on the previous page. In order to find the solution set, you must compare the two pieces and either take all or take what is in both. The challenge is in knowing what numbers are in each piece, and for that you must solve each piece separately. So in example number 9, I wrote two inequalities that are much more complicated than the inequalities you saw on the previous page. I worked them out for you, and if you would like to study the work, I would suggest that you pause this and come back and look at it when you're all finished. I used the Venn diagram for less than or equal to 4. I used the Venn diagram for bigger than or equal to 1.6. And means in both, and so I chose the section that was in both, and I summarized it with set builder notation. What worksheet would be complete without an opportunity to practice one completely on your own? This time I gave you an OR to work on with two pieces that you have to solve on your own in order to see what you actually have. At the bottom of the example, I gave you what I got as my solution to the problem. It's possible that my solution is the wrong solution. I do occasionally make mistakes, and if I did, I would certainly like to hear about it tomorrow. If, however, it wasn't my mistake, but your mistake when your answer doesn't agree with mine, a very, very important tool that you have to perfect is finding the mistake you made on your own. So one way or the other, we're going to sort it out, whether or not this is the right answer or it isn't the right answer. And if it isn't the right answer, then we're going to have to help me sort out my mistake.